Okay, let's start the lesson. Last day, we have discussed about basic electronics and electronic circuits. Today, we'll be continuing that lesson. And please open the DC circuit construction kit. That is basically PHET simulation. I will send you the link. Okay. Here, I have sent you the link to the chat. You can open from there. And please note that you need to open after like opening this, you need to open the lab, right? Not the intro. Please go to lab, right? So today we will study more about concept related to electricity. Mainly, what is voltage and what is amperage that we need to discuss. Okay, in order to discuss that, first of all, I would like to take a battery. Okay, and in this battery, there is an energy stored inside the battery that can be measured using the voltmeter. Okay, let's put the black end to the negative end, the black side, and the positive. This is the red end, that is positive end. Let's keep it here, and you can see when you are touching, it measures the voltage and it says it is 9-volt battery. Typically, when we purchase battery, okay, think about that, okay, remote, air conditioner remote or TV remote. Can you find a battery of TV remote or air conditioner remote now? So please look around, try to find a battery. You can turn on the cameras now. You all can turn on the cameras, right?
Is it okay to get a World Cup?
Yeah, in anything, any battery around you, you all can turn on the cameras now, right? Please. Shannon has already done, so Harindu, yes, Chaniru. Prarthana, please turn on the camera because it's very important.
So it's not working.
Your camera is not working, okay. Harindu is there, but his audio is muted. Lakmali, I think he don't know. Maybe now I think Harindu has joined. Okay, with the audio, please turn on the camera, Harindu, because like we are going to do small practical with the batteries. So if you can find out a battery around you, you can find any battery like around you. Okay, Chaniru, do you have any battery with you?
No, but I can find if you give me a 1 minute.
Oh yeah. Okay, already. Okay, Shannon already has found that. Shannon can. Okay, I cannot see that properly. Oh, okay. Okay, I can see that is energizer battery. Yes. So can you read? There is a V symbol, volt symbol. So what is the voltage of that battery? It is there in the battery. In the battery, it is mentioned. What is the voltage of that battery? Normally in the battery.
So you mean the warning of it?
Voltage. Voltage. That is sign V sign. You can see some V sign. V. Simple, okay, capital V basically. 1 point something V.
1.5 V.
Yes, 1.5 V. Okay, that's great. Chaniru, yes, what is there, Chaniru? Harindu, can you turn on the camera, Harindu, please? Because for this lesson, it's very important. Please find a battery. Yes, Chaniru, have you found them?
Excuse me, sir. I found 3 batteries of 3 sizes.
Huh?
One is 1.5 volt.
Okay.
And the other one is also telling the similar thing, but it's just
size is small.
Yeah, this and this.
Okay. One has one is called AAA size. The next one is called a AA size.
Okay.
Yes. Okay. Okay. Good. Mostly, the batteries that you can find around your home are AAAs or AAs or A's. So what is this AAA, AA? Okay, A, AA, and AAA. So what are these batteries? Let's see what are these AAA, AAA batteries. Okay. These are basically the sizes of the batteries, right? So here, let me show this image, and you can see these are different type of batteries. Okay, in this image, they have mentioned. Okay, I think you have, like, some of you found AAA batteries. AAA batteries come in for this AC remotes, TV remotes. We are using AAA batteries, right? Mostly. Then there are
Excuse
4A
me, sir.
batteries. Yes.
I find all 9 battery.
Volt 9 battery. Okay. Volt 9 battery is this. This is PP3 battery. Right? This is Volt 9 battery. And AA battery is this. AA battery. And there are C or D batteries. C or D type batteries. This is AA. Double A. Yes.
I have the PP3 battery. The
Okay.
I found a D battery.
That is 9 volt, right? Can you see? Can you check? That
It's
is
not
basically...
1, it's 1.5.
Oh, 1.5. Oh, can be. Normally it is 9 volt, but maybe, like, so normally this is 1.5 V. Most of these batteries are 1.5 V. And let's see another picture. And here also you can see them. This is D type battery, C type battery, AA, AAA, and this AAA, 4A batteries. And this is 9 volt battery. We can call 9 volt battery also. Yes.
What's the type of this battery? D.
Wait. Yeah, which one? It is D type. D type.
Okay.
D type. Yeah. D type. Right?
Thank you.
Okay. This is AA, AAA, then 4A. Like different batteries are there. And actually you need to know which battery is basically suitable, because when you're buying a battery, you need to tell that I need AA battery, I need AAA battery, because we cannot say like chuti battery akkone, ita chuti battery akkone. And that is why, right? Normally, these batteries are having sizes, right? These batteries are having sizes, different batteries, different sizes. And here, this is another format, right? This is so normally coming for the rechargeable batteries. So these batteries are different from the other batteries. Different formats are there. Right. Okay. You can also search in Google battery sizes and names. So what are the battery types, sizes, and names? Okay, this is another one. Let's open a new tab and let's try to identify this. Okay.
I found a button battery.
Yes, that is called coin cell battery. Coin cell button coin cell battery. Coin cell battery. Basically coming for watches and all.
Clocks.
This coin clocks.
Sir, I found it in my key tag.
Where?
In my key tag.
Key tag. Oh, yes, can be. And also for this, this is coming for vehicle keys also. And here see PP3 or E block or 6F22, different names. But this is basically, mostly this is 9 volt, but then can be some other measurements. You can see the C type battery and D type battery, F type battery, and N type battery. Yes.
Excuse me, sir.
Yes.
For what purposes do we use F-type batteries?
Where? These are basically used for rechargeable things, rechargeable fans, solar panels, maybe battery packs for the toys, even for Arduino board power in Arduino or robotics circuits. Mostly we are using. So there's another name. This name is commonly used. 18,650. Right. This 18 is basically the yes.
If we are using the batteries for other purposes, what is the battery we are using for a normal circuit?
It depends on the requirement, right? You can use different batteries, like even coin cell battery you can use for a small circuit. But if you are powering Arduino board or something, mostly we are using this kind of batteries, this 16 650 batteries. This is mainly used for Arduino boards, like because these batteries are rechargeable. But you can even use AA or AAA batteries. There is also possible. Few AA batteries can also be used. It depends. Sometimes we are using this LiPo batteries or LiFi batteries. Okay, this is some different one. LiFi also rechargeable. These are also used for the drones and all, right? LiFi and then LiPo, LiPo. Okay, LiPo batteries also we are using. LiFi batteries also we are using. So these are also batteries, but these batteries different from that battery that we saw earlier. And there are like nickel cadmium batteries, nickel cadmium cells or nickel cadmium batteries.
Excuse me, I found a smartwatch and a phone battery.
Smartwatch and phone battery. Okay, in mobile phones there are like LiFos, LiFi batteries, not LiFo batteries. Mobile phone there are sometimes nickel cadmium batteries are there. So different batteries are there, right? Here, so the type of mobile phone battery is also different, and also there are lead acid batteries. Lead acid batteries are the large batteries coming for the vehicle. Okay, lead acid cells or lead acid batteries are large batteries which is coming for vehicles and maybe some other purposes. Okay? This battery can also be used. Therefore, different batteries are there. I just gave you some idea, but you just search. There are a lot of batteries, right? And this is simple cell.
Excuse me, sir.
Yes.
Is a simple cell also a type of battery?
Yes, simple cell is also battery, but only problem is like we cannot use simple cell is not much durable, but we can use that as a temporary or experimental battery because it's not that durable battery. And also that lemon battery is also there. You know the lemon battery? But we cannot
Yes, sir.
actually use that for long term because very small current is there in the lemon battery. And there are like potato batteries. Have you seen
No, sir.
potato cell? Yeah, this is potato cell, not this potato battery cell. Otherwise, you will see the cell and this is potato battery cell. Okay, very small current can be generated using that also. Okay, and lemon battery is also similar to this. Potato battery is also looks like the lemon.
Sir,
battery.
what about apples? What about apples?
You want to use apple battery? Is it? Yeah, any because there are acids, we can use it. When there are acids, we can use that. You are asking about eating apple, which is eating, or which one? This apple. This apple or the other apple?
Yes, sir.
This apple or the other apple? The fruit. Yes,
This apple, sir.
this
Not
apple.
yet.
Okay. This apple like mainly leafy like thing, but you can use this apple also as a battery because they are acid. They are acid, and this apple can also be used for generating electricity with the copper and zinc. Because anything with acid and water in it can be used.
Can we use orange also?
Yeah, possible. Orange, lemon, lime, anything. Because it has acid as well as the watery interface, which is a conducting interface. Okay, you can see that here. Lemon, lime, anything can be used. Right? You can try these things. It will generate very small current. Right? Very small current. Not that durable also. Right, solar cell or the solar one is another one. Likewise, different energy sources are there in the world. In Apple, here, let's see, Apple battery chemical composition. Mostly it is, you can see, it is, okay. This is lithium ion, right? Lithium ion one. You can see it is lithium ion. Nickel, cadmium, lithium ion, LiFi, LiFo, LiPo, and different versions are there. Okay, we have discussed about lot of batteries, but according to your book, you don't want to discuss that much of batteries. They have only mentioned about the simple, not simple cell. Simple cell is also there, but we are discussing about normal battery, which is like this. Okay, then voltage is one of the main properties of the battery. We have learned that voltage is one of the main properties. The next thing is the amperage. Okay, let's see a battery, a close view. Voltage you already saw, and ampere in a battery. Okay, let's see, let's take a double A battery, which is more common, or you can take other batteries also. Okay, this is called alkaline cell, right? Alkaline cell. Okay, voltage is basically, right, voltage of this battery is typically 1.5. Some cases can be more than that also, but typically it is 1.5. You can see it is typically 1.5. Okay, but amperage, but you cannot exactly tell the ampere rate, but you can give, it is possible to give some values, because the ampere is basically, ampere කියලා කියන්නේ ධාරාව, voltage කියලා කියන්නේ විභවාන්තරය. විභවාන්තරය කියලා කියන්නේ නිකන් ශක්තිය වගේ. This is energy. Okay, this is the energy in the battery. 1.5 is the energy of that battery. And amperage is depend on the equipment that you are using here. See this image, I will try to explain, but this concept is a bit harder for you sometimes. So this is given as ampere hours. Ampere hours. Okay, this is basically experiment done with a battery with certain ampere hours. This test compare the different manufacturer cells 2 amps discharge rate. The manufacturer codes are listed above. Note that 2 amps discharge rate, discharge radio shock discharge rate. The radio shock has higher voltage and more amps hour than the Duracell. This is the comparison basically. Okay. Here you can see ampere hours means if 1 ampere is taken, how many hours? That is basically the measurement. If 1 ampere is taken from the battery, how many hours it will last typically. Because different circuits are taken differently, take different amperes. So it depends, right? Battery, like let's say we have used the battery in a toy, same battery in the torch. Sometimes torch will last for a long time, but toy will not last. Sometimes it's the reverse. It is based on the amount of ampere that you take out from the battery. That decides the discharge time of particular battery, right? That decides the discharge time of particular battery. It's like this. Okay, let's assume you have a water tank. Assume you have a water tank, water bucket, and you are taking this water out of this bucket. You are taking water out of this bucket using a tap. Okay, What if the tap is large and what if the tap is small? Yes.
When
Tap
the
එක ලොකුඩම් මොකද වෙන්නේ?
when the tap
Yes,
is
yes.
large, the water is going very fast, and the water will get finish in a very speed. But when the tap is small, it will take a long time to finish the water.
Exactly. Very good. Yes, when tap is large or when this the line is large, the water will, we can take water quickly. We can take water out quickly. But the thing is, within very short time, it will be over. Within very short time, it will be over. But in the other hand, if this line or the tap is very small, it will last for a long time. It will be there for very long time. If this is small, it will give us water for long time. But anyway, there is a maximum amount of water which this tank can give. Within a very short time or within a very large time, there is a maximum amount of water this can give. So that is marked as MAH. That is marked as MAH in a battery. Battery එක MAH කියලා ඔක තියෙනවා නම් MAH කියලා කියන්නේ milliampere hours. නැත්නම් AH ampere hours. Ampere hours තියෙන ටික ලොකු battery වල. මේ බලන්න. Just see this. සාමාන්‍ය bike battery වල වගේ නැත්නම් toy කියන ඔය drive කරන car වල වගේ තියෙනවා AH තියෙන batteries. Here 12 volt 12 volt 12 AH battery කියලා කියන්නේ battery voltage එක මේ තියෙන battery voltage එක 12යි. ඒ කියන්නේ battery ධන සහ ඍණාග්‍රය අතර තියෙන විභවාන්තරය. the gap එක. ඒ කියන්නේ volt 12ක මේ එකක් තමයි තියෙන්නේ. volt 12ක් කියන අපිට කරන්ට් එකම වදින්නේ නැහැ. මේ battery ඇල්ලුවා කියලා අපිට කරන්ට් වදින්නේ නැහැ. හේතුව volt 12 කියන්නේ එහෙම ලොකු විභවාන්තරයක් නෙමෙයි. හැබැයි ලොකු විභවාන්තරයක් තිබ්බොත් අපිට කරන්ට් එක වදිනවා. දැන් අපේ ගෙදරට එන voltage එක මොකද්ද විභවාන්තරය? What is the voltage typically comes to the devices at home? Yes. Have you checked? Anybody? You can take a device and check. Yes.
No.
You can take, maybe you can see your iron. It is mentioned in the iron or rice cooker. Or you can check iron or rice cooker or heater or refrigerator or any device which is connected to the direct current. You can see the voltage. What is the voltage mentioned there? Take any device and see that. Any equipment, kitchen equipment or fan or anything. There is voltage mentioned. Ekki voltage එක mention කරලා තියෙනවා. කීයද තියෙන්නේ කියලා බලන්න. See what is the voltage mentioned. TV එකෙත් පුළුවන්. But TV එක පෙරලන්නේ මෙපා පිටිපස්සේ ගහලා තියෙන TV එකේ. Check it and tell me what is the voltage there. No one checked? Hello?
Yeah.
Yes, what is mentioned there?
Wait.
Not mentioned?
Wait.
Okay, take your time and see.
Excuse me, sir.
Yes.
Sir, my glue gun voltage is 20 voltage.
Blue gun 20
So I
voltage.
found the voltage of an iron.
Okay, iron, what is the voltage?
2600 voltage.
Oh, what? W is for watt, right?
Yes.
That is wattage, right? That is called wattage. What කියලා කියන්නේ ඒක what එක මම කියලා දෙන්න. What is what I will tell you, right? Wattage is different. Check the voltage. V is voltage, W is wattage.
So I'm telling about the voltage, not the sorry, what? Sorry, what?
Wattage. It should be wattage, right?
W, sir, not
W is wattage. See whether simple V, capital V is there, capital V somewhere.
So it's 25 voltage.
Voltage 25. What is the device? You are telling about W, right? W is what? W is what? V is what?
Okay.
Okay, W is what? V is volt. See whether V is there. Okay.
Excuse me, sir.
Yes.
Sir, our TV voltage is 230 voltage.
Very good. That is correct. That is correct. Basically, home power supply is 230 volt. Right? Our home power supply is 230 volts. So if any device directly connect in that, right? If any device directly connecting that, we call that 230 volt. So what is wattage? Wattage is basically used to measure the consumption. Right? Our units basically when you are calculating the electricity bill, units are measured. This unit එකක් කියලා කියන්නේ megawatt hour එකක්. Okay, so let's search what is unit in electricity bill. That is basically, okay, here not megawatt, sorry, not megawatt hour, sorry, I mistake. 1 kilowatt hour. 1 kilowatt hour, right? 1 kilo in Sri Lanka කියලා හමුනේ. Country to country can be, okay, here this is kilo kWh, kilowatt hour. What is that? Okay, let's see කොහොමද අපි unit එකක් යන්නේ කියලා බලමු. දැන් මට කිව්වේ කවුද 2300 කියලා කිව්වා නේද මොකක් හරි device එකක්. What is that device?
Our TV.
2300? 200 තියෙන්නේ පුතේ. කවුරු හරි කිව්වා 2500ක් තියෙනවා කියලා මොකක් හරි.
Our TV's voltage is 230.
Yeah, 230 voltage. හරි. Watt එක කවුරු හරි කිව්වනේ ඉස්සෙල්ලා. Watt අගේ කියලා. මොකද්ද පුතේ? කීයක් තියෙන්නේ?
2030.
2030 or 2300?
Sorry, 2003. Yes, 2300.
2300 or 2500?
2600, sir.
2600. What is the W name? W.
Yes, sir.
Okay, W. හරි. ඒ කියන්නේ එයාගේ device එයා තියෙන එක, එයාගේ උපකරණය, ගෙදර තියෙන උපකරණය. හරි, මේක මම කියලා දෙන්නම්. හැබැයි ටිකක් විතර ඇඩ්වාන්ස් කමන්න මේක මතක තියාගන්න. ඔයාලට ගෙදර බිල් එක හදාගත්තේ වැදගත් වෙයි. එහෙම ගොඩාක් ඇඩ්වාන්ස් නෑ. හරිද? කොහොමද අපි මේක මනින්නේ? හරි. Let's go and write down this, right? How this wattage, what is the relationship? You don't need to know. නේ මොකද අපේ ගෙදර තියෙන උපකරණ. හරි, මම එක දෙන්නම් ඔයාලට හොයාගන්න තව උපකරණවල. ඔන්න wattage එක අපිට කිව්වා යාගේ උපකරණේ කීයද? watt කියලා කියන්නේ අපි. හරි. watt අගය කීයද? 2600ක් කියලා. ඒක watt. මේක සමාන වෙනවා පුතේ 2.6. මේක 1000න් බෙදුවම kilowatt 2.6කට සමානයි. හරි. එතකොට මේක පාවිච්චි කරන ඇම්පියර් ගාන ඕනනම් අපිට හොයා ගන්න පුළුවන්. If you want, we can find the ampere. Because this there is an equation P equal VI. V is the voltage and I is the ampere. We already know 2600 is our wattage. That is equal to 230 into I. Then you can see what is I. And it's basically using more than 10 amperes. Ampere 10ක් විතර එයා පාවිච්චි කරනවා. ඔයාගේ ওই කේබල් එකේ size එක තීරණය වෙන්නේ කේබල් එක ටිකක් මහත ඇති ඒ වාගේ මේක. ඒ කියන්නේ හේතුව ඇම්පියර් 10ක්වත් යනවා. ඔකට පොඩි කේබල් එකක් දැම්මොත් ඒක පිච්චෙනවා. හරි ඒක ගැන අපි දැනට වැඩි කතා කරන්න නැතුව ඉමු. හරි මේකත් අපි පැත්තක තියලා අපි බලමු මොකද්ද මේකට වෙන්නේ. හරි. What is this electricity unit? Electricity bill එකේ unit එක මොකද්ද? I said kWh kilowatt hours. හරි kilowatt hours. එතකොට හරියන් මේ ඔයා ඇත්තටම මේ device එක what is this? This is iron or what is this? Or heater? What is this
Iron,
device?
sir.
Iron. හරි මේ iron එක ඔයා පැයක් ගහලා තිබ්බොත් kilowatt කීයක් යනවද පැයට? Yes. Yes. 2.6 kilowatt යන ඒකක kilowatt hours නේ. ඒකක අඩුම ගානේ 2.6ක් විතර යනවා. ටිකක් වැඩිපුර යනවා නේද කරන්ට් එකේකට. ඒ කියන්නේ ගොඩක් ලොකු කරන්ට් එකක් පැයක් ගහලා තිබ්බොත් ඒකක දෙකක තුනකට ලඟ වෙන්න යනවා. Okay, let's write about the voltage, wattage and okay. So let's write about that first. Please write the heading of your heading as electricity. Electricity. Vidyutaya. Okay. So please write down about the electricity. Please write down this. This is very important. These key points are very, very important, right? Wait. I will show you the note. First, I will show you the note. Just that I kept. Just give me 1 minute. Okay, as I said earlier, volt is basically is the force, right? Basically, why a river flows? Because force of water, right? Because if it is a waterfall, a short waterfall or maybe a tall waterfall, and you have like very short one and very tall one with a great height. Which has more energy? Which has more energy? Tall one or the short one? Yes.
The long one?
No, I'm asking about a waterfall. Right? There are two waterfalls. One waterfall is very tall. The other one is very short. One height of one waterfall is very high. Height of the second waterfall is very low. If you go and try to touch water which is flowing, which has more energy, which has more power? Yes, which has more power? Short one or the tall one?
The tall one.
Tall
Yes.
one?
Yes, the one which is having more height has more power. That is the nature. It's like this. If voltage, like, okay, think that you go and try to bath in that waterfall. If waterfall is very short, doesn't matter. But if waterfall is very tall and more high, you have to be careful, because if it hit, it might hurt. Right? It might hurt because of the height. The energy is high. Volt is like that. When it is 12 volt, 1.5 volt, no one cares. 1.5 volt battery can current එක වදිනවද? නෑ නේ ඔය හොඳට සෙල්ලම් කර ඉන්න ඕගොල්ලෝනේ අතරගේ. එහෙම ප්‍රශ්නයක් නෑ. හැබැයි 230 230 volt, which is coming from the main line, it is more powerful. 230 ඔහම අල්ලගෙන ඉන්න බෑ ඔයාලා. අල්ලන්න යන්නත් එපා. 230 කියන කරන්ට් එක වදිනවා. වැදිලත් ඇත්ති ඔයාලට සමහරවිට. නේද? ගෙදර ලයින් එකෙන් කරන්ට් වැදිලා තියෙනවද? නැද්ද?
නෑ.
ඒක. ඒතර ඒක අර බැටරිය වගේද නැත්නම් ගොඩක් පවර්ෆුල් නේ. 230 නේ. ඊළඟට ඔයාලා දකින්නවද පාරේ බලන්න පාරේ ගහලා තියෙනවා. ලයින්ස් වල 11000 volt, 33000 volt ගහලා තියෙනවනේ high voltage කියලා warning කියලා. Have you seen this one, this warning? 11,000 volt. 11,000 volt. මෙහෙම ගහලා තියෙනවා line එක. 11,000 volt. Okay. These are basically transporting 11,000. But some are more powerful than. Some are having 33,000 watt. Some are 33,000 watt. Those are more powerful. But these voltages, you can't even go closer. Right? You can't even go closer to these.
So if we are trying to go closer, then we need to stop the whole electricity.
What? If you want to go closer?
Yes. Closer to
What we have to, yes, disconnect the main voltage. We have to disconnect the main node. Otherwise, what will happen? It will blast. It will blast. Not just shocking, it will blast. Like even remaining sometimes cannot be found. This is very powerful. Don't even think about this. Sometimes I think you have seen some crows and all. When it hits the line, it will blast. The transformers, everything. Here you can see it's firing, right? When electric shock happens, so it's not that. It's very powerful, very powerful.
Some bats are died because of the current.
Yes. Because 11,000, even not 11,000, 230 is deadly. 230 is deadly. 11,000 is anyway deadly. 33,000 is more. Right? Therefore, so this voltage is basically very okay. Then amp is basically amount of water in the waterfall. If amount of water is high, amp is high. Amount of water is low, amp is low. Like that. The amount of current. What is? That is the power. How powerful? That is basically when you multiply ampere and watt, VNA, what comes? That is say how powerful this is. Okay, please write down this very quickly. Please write down this highlighted thing very quickly. And I will give the formal definition in your tune. Please write the highlight. This is simple format. Okay. One thing that we have learned is